Radzien here. Today we are diving into a common issue faced by developers, deleting inactive user data from our system. We'll be working within the TypeScript repository of the productivity app Incurser. Even so, the source code for this project is in a private repository. You can find all the reusable code in the RadzionKit repository. Incurser is a paid web application that offers a free trial period. During this trial, only a fraction of users convert to paying customers. Many users try the app and never return, leaving their data stored in our database and S3 storage, which incurs costs. To address this, we'll create a Lambda function that runs daily to clean up inactive user data. First, let's talk about the environment variables. The getEnvar function is our source of truth for all environment variables needed in this package. It throws an error if any required variable is missing. Our logic is straightforward. If a non-paying user hasn't opened the app in the last 60 days, we'll send them a warning email. If they still haven't opened the app in the last 90 days, we'll delete their account. Tracking the last visit is simple because the app queried the user state whenever they open the app. We update the user with the last visit at field within the user resolver. If you're interested in learning how to implement a backend within a TypeScript monorepo, check out the corresponding YouTube video in the description. First, we fetch all the users from the database, limiting the query to only the necessary fields. Currently, the system doesn't have many users, but as the data grows, it would be more efficient to process users in batches. We use DynamoDB as our database and employ the scan operation to retrieve all users. With the help of the getBigParams function from the RadzionKit repository, we can generate all the necessary parameters to apply the projection expression and query only the required attributes. The totalScan function handles pagination and waits until there are no more items to fetch by checking the last evaluated key field in the response. You can find the implementation of the totalScan and fetch all functions in the RadzionKit repository. Once we have all the users, we proceed by iterating over each user and wrapping the operations within promise all to wait until all the promises are resolved. If we fail to handle one of the items, we won't stop the process. Instead, we'll report the error to Sentry via the report error function, which supports adding context to the error for a better understanding of the issue. First, we check if the user has a free trial, an active subscription, or a lifetime deal. If any of these conditions are met, we skip the user. Next, we check if the user has received an account deletion email and if they haven't visited the app after the email was sent. In our logic, we ignore account deletion email sent if the user visited the app after the email was sent. Then we calculate the date when the account should be deleted and compare it with the current date. If the date has passed, we delete the user. If the user hasn't visited the app for a certain period, we send them an email about the account deletion and update the account deletion email sent field. When deleting a user, we first remove the user item from the users table. Next, we proceed with removing the users folder from the S3 bucket. Finally, we update the scoreboard tables and features table as they might contain references to the user. While Incurser doesn't have email marketing campaigns, we still save the user's email to a table dedicated to user emails. This way, even if we delete the user, we can still reach out to them if needed. To notify the user, we send a plain text email informing that their account will be deleted if they don't visit the app within the next 30 days. We send emails using AWS SES. Since we might trigger a large number of emails at once, we use the make function rate limited protect function from the RadzionKit repository to rate limit the function, ensuring we do not send more than 14 emails per second. We'll host our Lambda on AWS using Terraform to manage our AWS infrastructure. The configuration begins with defining the S3 backend for Terraform state. We create an S3 bucket for the Lambda function code and set up the AWS Lambda function resource with details such as memory size, handler, runtime, and environment variables. An IAM role and policy grant necessary permissions, while CloudWatch Events rule triggers the Lambda function daily, ensuring the cleanup runs automatically. That's it for today's video. I hope this gives you a clear understanding of how to handle inactive user data in your application. Don't forget to check out the description for links to the RadzionKit repository and the corresponding YouTube videos for more detailed guides. Thanks for watching and see you in the next.